Hi everyone, my name is Neha and this is the second lecture on Introduction to Automation. In this lecture, we are going to learn about loading error. Loading error occurs when the pot wiper is connected to a circuit with an input resistance that is not considerably higher than the pot's resistance. So here you see this is a potentiometer sensor and this is a 0 voltage which is connected to the ground, and this is the 10 volts which is connected to the supply, and this whole is the resistance. So in this potentiometer circuit it will work properly when the same current will flow through the entire pot of the resistance. And if the wiper is connected to some interface circuit and that interface circuit has some resistance, then in that case the loading error can occur. So here in this first example, you see this shows a pot is unloaded and no error. So in this, why we do not have error? Because the resistance here is infinite. The interface circuit resistance is infinite. So therefore, the resistance will not basically interfere with the potentiometer, and therefore we do not have the loading effect. Whereas in the second circuit, we see that 100 kilo ohm resistance is attached, and which is causing a loading error, and you see that some amount of current will flow into this resistance path, and you know that current tries to follow a low resistance path. So this is the low resistance path it might get, and would like to go to the ground from here, and that will create a loading error. Now this loading error, this can be given by this formula VNL minus VL, where VNL is the output voltage with no load, and VL is the output voltage with load applied. Now we are going to see one problem based on the loading error. So this problem says a 10 kilo ohm potentiometer is used as a position sensor, and we'll be using the same figures from the previous slide. And assume that the wiper is in the middle of its range. Find the loading error when the interface circuit presents an infinite resistance, and second, the interface circuit presents a resistance of 100 kilo ohm. So for the first case, we know that this is the ideal situation where interface circuit resistance is infinite, and it is so high that there will be virtually no current in the pot wiper. And so we can calculate the let's see the previous circuit. So I'm talking about this case when the resistance is infinite, and in this case we can calculate the potentiometer voltage, and that can be calculated by taking this total voltage of 10 volts and multiplied by the 15 kilo ohm and divided by the total resistance, and by that we will get this voltage, which is going to be 5 volts. So by using this formula we got the 5 volts resistance. Now for the second case, which it says the interface circuit presents a resistance of 100 kilo ohm. So let's go back to this circuit. Now we have this interface resistance which is here of 100 kilo ohm, and so we will need to use a voltage divider rule again to compute the potentiometer voltage, but this time the lower voltage is a parallel combination of 5 kilo ohm, which is here 5 kilo ohm, and the 100 kilo ohm. So when you take the parallel combination, then that value will be your this total equivalent voltage, and then you can calculate the voltage across this. So let's see next. So by this formula we have calculated the parallel combination of 5 kilo ohm and the 100 kilo ohm, and we got 4.76 kilo ohm. And then after once you obtain this value, then you will use this value to calculate the pot voltage. So pot voltage can be calculated by this formula. So these are the same formula. The only thing here we are using the parallel combination. So we see that this voltage is 4.88 volts. Now using the loading error formula, which says VNL minus VL means output voltage with no load subtracted from output voltage with load applied. So when we use that formula, we will get 0.12 volts. We will subtract these two. This is without load and this is with load. So when we subtract them, we will get 0.12 loading error. So this is the way how you calculate the loading error. Now next is the linearity error. And linearity error states that it is the difference between what the angle really is and what the potentiometer actually reports it to be. So in this graph, we see this is the graph between the resistance and the shaft angle. So if you see this figure, this is the total resistance, and corresponding to that we know that we have some angles. So this graph is drawn between them, and the resistance will come out to be like this, very linear in the ideal case. But in actual case or in practical, the resistance curve will not going to be this much linear. It will have some loading error, and due to what we have a curve like this, and by this we can calculate the delta R. This is the difference between the actual resistance and the linear ideal resistance which we expect. So this is called your delta R, and with this value of delta R, we will know that how we can calculate the linearity error. So let's move on to the next slide. So here we see the formula for linearity error, and which says delta R by R total, where delta R is the maximum resistance error and R total is the total pot resistance, and this is multiplied by 100 to get the value in percentage. And this percentage range, it will lie between 1.0 and 0.1. Now, when you want, when the potentiometer is used as a position sensor, then the output voltage is going to be directly proportional to the angular position. So linearity error can also be expressed with this formula, where delta theta is basically represents the maximum angle error, and theta total is the total range of the pot, and multiplied by 100 you will get the error in percentage. Now we are going to see one problem based on linearity error. So this problem says a single turn pot 350 degree has a linearity error of 0.1% and is connected to a 5 volt DC source. Calculate the maximum angle error that could be expected from this system. Now to calculate the maximum possible angle error, we will use this formula of a linearity error. We have made a little bit change, where we have put delta theta is equals to linearity into theta total divided by 100. Theta total we already know is 350 degree given in the problem. Linearity error is given which is 0.1. and we have to find the maximum angle error, which is delta theta. So putting all these values, when you'll calculate, you will get 0.35 degree, and it says if this pot were in a control system, the controller would only know the position to within 0.35 degree, or about 1/3 of the degree. So this was a problem based on linearity error. Now next we have is the resolution, and resolution is refers to the smallest increment of data that can be detected and or reported. In digital system, this resolution is refers to the value of least significant bit, because that is the smallest change that can be reported. And if we see the formula, then this resolution can be calculated by this, where the smallest change in the resistance will be divided by the total resistance and multiplied by 100. That will give this in the percentage. So this is the same thing, delta R by R total into 100. Now let's see one problem based on resolution. So this problem states that the resistive element of a wire wound pot is made from a 10 inches of 100 ohm per inch resistance wire and is wound as a coil of 200 loops. The range of the pot is 350 degree. What is the resolution of this pot? You know by the formula, resolution is equals to delta R by R total. So we know we need to first find out the total resistance, and then we need to find out the resistance per loop, and then finally we can calculate the resolution. So the total resistance that can be calculated by this formula. So this is the formula which says total resistance is equal to R total is equals to 10 inches multiplied by 100 ohm by inches, and you will get 1 kilo ohm. Now you need to calculate the delta R. So that you can calculate by using this formula, resistance per loop. So 1 kilo ohm, and we know that the coil has 200 loops. So divided by 200 loops, you will get 5 ohm per loop. Now next, to calculate the resolution, you will use this formula, delta R divided by R total multiplied by 100. Delta R you already know, which is 5 ohm per loop, and R total is 1 kilo ohm. So you will put the value 5 ohm multiplied by 100 upon this should be 1 kilo ohm. So when you, instead of this ohm, here you will put 1 kilo ohm. When you put that value, you will get 0.5 percentage. So this is the way you will solve the problem based on resolution. So this is the end of the lecture. Thank you so much for watching.